A 3D shape, seemingly made of light, floats in midair. It's a familiar image in fictional visions of the future. But that fictional future may be a lot closer and a lot more real than you think.
We here at the electroholography group at Brigham Young University have created a display that is very much like the displays of science fiction.
But despite the similarity to the holograms of Hollywood films, these displays are different.
This image is not a hologram. We've demonstrated here that we can see it from the front, we can see it from the back, and in reality we can see it from almost any angle. And that separates it from technologies like holograms that can only be seen from a certain range of angles.
Scientists call these science fiction-worthy displays volumetric images.
A volumetric image is essentially an image that is taking up three-dimensional space. And our approach is that we're actually using a laser beam to trap a particle, and then we can basically steer that beam around to move the particle and create the image.
Like when you swing a sparkler around, a particle moving fast enough looks like a solid line and can be moved to form a shape.
We can think about this image like a 3D printed object. A single point was dragged sequentially through all of these image points, and as it did, it scattered light. And the accumulated effect of all that scattering and moving was to create this 3D image in space that is visible from all angles.
As well as taking up real 3D space, the images created by this single particle and a few low-cost lasers can be incredibly high resolution, up to 1,600 dots per inch. Although they're very detailed, the images created so far have been quite small, and they remain difficult to capture on video. Because of the video's frame rate, the display appears to flicker here, but to the human eye and to still cameras, the image appears whole. Rather than being used in epic space battles or to communicate with alien races, these kinds of three-dimensional visualizations may instead be used to train medical professionals for advanced procedures. They could also be used in aviation, providing busy air traffic controllers with more accurate and intuitive visual maps of how planes are moving around airports. To reach that point, though, researchers will have to first master the trapping and moving of multiple particles simultaneously in order to scale up the images to sizes larger than the tip of your thumb. Until then, we'll just have to settle for experiencing the future in miniature.